Okay, so here I want to do, without using the calculator, rank the following from smallest to largest. Okay, so what this is going to have us think about is what it means to compute the cosine value of something. And so if I think about these angles, I know that 18 degrees, that cosine is the x-coordinate on the unit circle. 18 degrees is over here. 12 degrees is even smaller. 155 is going to be way over here. 212 will be over here. 95 will be here. 85 will be here. Oops, 95 will be greater than 90. Oops. So 95 will be here. What was this? 155 and 212. Okay, and so if I think about the x coordinates here, the biggest one will be at the 12 degrees. So cosine of 12 is the very biggest. Okay, and then the next biggest will be when my angle is 18 degrees, then the x-coordinate associated with that is next. Okay, and then at 85 degrees, the x-coordinate associated with that is the next smallest, cosine of 85. Okay, and then cosine of 95 is actually negative, right? So cosine of 95 is negative. Okay, and then let's see, is 155 or 212 going to be smaller? So let's see, how far away is 155 from 180? 25 degrees, so the reference angle there is 25. And what about for 212? 212 minus 180 is 32, so the reference angle there is 32. And so that means that the x-coordinate, let's see here then. So that means that maybe I'll erase this a little bit and make this. Okay. So that means that this is 32, which is a little bit bigger, and that one's even smaller. So, okay. And so, so cosine of 212 is going to be next because that x value is there and it's a negative. So cosine 212. Okay, so hang on. Let's see if I write this down in order. So biggest, smallest. Smallest is cosine 155. And then biggest is going to be cosine 12. Okay, and then we'll have cosine 212, cosine 95, cosine 85, cosine 18, and then cosine 12. And that's the biggest. Okay. Find all angles between 0 and 360 that have the same cosine as 240. So let me erase a little bit over here. And so I want to do, so 240 degrees is, let's see, so that's going to be here. Okay, and so the reference angle there is 60 degrees, and I want it to have the same cosine, so that same x value. So if I go straight up with a reference angle 60, it'll be that one. So 180 minus 60 is 120. So the answer here is 120 degrees. And if I want it to have the same sign as 315, so 315 is going to be this one here. and the reference angle is 45 degrees. And so if I want it to have the same sign, that's the same y component there. And so the only other place that would have the same y component would be here. And with the reference angle 45, so that's 180 plus 45. So that's 225. Okay, so if we just remember the cosine is related to the x-coordinate and the sine is related to the y-coordinate. Number 3, find the coordinates of the point at angle 156 degrees on a circle of radius 7.8 centered at the origin. Round to 2 decimal places. Okay. So if I am, let's see. So what I need to do here is draw my angle first. So it's 156 degrees. Here somewhere, and it's on a circle of radius 7.8 centimeters, and so I know that my x and I can label my x and y here, and so I know that my angle there is 156 degrees. So I know that sine of 156 degrees is going to be y over 7.8. So y is going to be 7.8 times sine of 156, which is, let's see, I need to make sure I'm in degree mode. And so I get 3.17. Does it say round to 2 decimals? Okay. And I know that cosine of 156 is going to be equal to x over 7.8. So x is equal to 7.8 cosine of 156, which is negative 7.125. So maybe 7.13. Round. So the coordinates are negative 7.13, comma 3.17. Okay, number 4 says theta is an angle in the first quadrant with cosine theta equal A and sine theta equal B. Okay, evaluate each of the following in terms of A or B. Okay, so if I did cosine of theta plus 180, that's going to be down here. So this is theta plus 180. So that's going to be negative A, negative B. And so the cosine value of that is going to be negative A. And if I do sine of 360 minus theta, so 360 is all the way around minus theta, that's going to be down here. The coordinates at that point are going to be, the x is still the same, but the y is negative. And so the sine value is going to be negative b. Okay, the next one says radians arc length in the unit circle. A weather satellite orbits the Earth 500 miles above the Earth's surface. What is the radian measure of the angle through which the satellite moves in traveling 600 miles along its orbit? The radius of the Earth is 3,960 miles. Okay, so I know that I have here a satellite, and then it's so the total radius from the center of the Earth all the way out is going to be 3,960 plus 500 is 4,460. and then it's moving 500 miles, oh sorry, it's traveling 600 miles along its orbit. So this arc length is 600. And so what does radian measure mean? Radian measure means I'm measuring the arc length in units of the radius. So the angle theta is equal to the arc length in units of the radius. So that gives us 0.134 radians. The next one says find the exact coordinates of the point of an angle 7 pi over 6 on a circle of radius 2. Okay, so you can think about the angle 7 pi over 6. So let's see, 6 pi over 6 would be 180. 7 pi over 6 is one more. And if I think about that on the unit circle, I'll pretend that's a unit circle. It's square root of 3 over 2 and negative 1/2. Okay, and then this is 1. And if I scale that up by 2, that means I multiply everything by 2. Then this would be length 2. This would be square root of 3 over 2 times 2, so square root of 3. And then this would be negative 1/2 times 2 is negative 1. So the coordinates will be, negative square root of 3. This was negative square root of 3 over 2. So negative square root of 3, comma, negative 1. Okay, last one. In the circle of radius 5 centimeters, which is shown here, find the length of the arc from 0 to 5 to point A. Okay, is 4.4, so that's the arc length. Find the coordinates for point A and the length D, the straight line between 5, 0 and point A. Okay, so the radian measure of angle theta is the arc length, 4.4, measured in units of the radius, which is 5. And so that is 0.88 radians. Okay, and so so if I want to find the coordinates of that point, I know that sine of 0.88 radians is going to be equal to y over the radius, which is 5. And so y is equal to 5 sine of 0.88, which is, if I make sure I'm in radian mode, 3.853. And then x is going to be r, which is 5 cosine of 0.88 for the same reason. And I get 3.1857. Oh, I guess if I round up, I go to 4 here. Okay, so the coordinates of the point A are 3.186, comma, 3.854. Okay, and then the distance between 5, 0 and that point is going to be this. So the distance is going to equal square root of x2 minus x1 squared plus y2 minus y1 squared, which is, that's the difference in the x's over the difference in the y's. Okay, so the difference in the x's is going to be square root of 5 minus 3.186 squared plus, and the difference in the y's is going to be, well, that height and the y's is just 5. So if I do that, I got 5.319 is the length of that D.